Mrs. Wong is the president of a swimming club. She devises a training program for members of the club. Members swim 10 lengths of a swimming pool. The time taken to swim the first length is 40 seconds, and the time taken to swim the last length should be 25 seconds. That means successive timing should become lesser and lesser. So the time taken for each of the 10 lengths are in arithmetic progression. Okay, so from 40 seconds it is going to drop all the way to 25 seconds. Find the total time taken to swim the 10 lengths using Mrs. Wong's program. So let's look at how we can do that. First length is 40 seconds. So that is actually the first term, right? So which is what we call as A. So A equal to 40. Now we are told that for 10 lengths, right? So n is equals to 10. Then we are told that the time taken to swim the last length, which is the 10th length, is 25. That means T10, okay, the 10th term should be 25. Now what does it imply? So the term value is given by, since it is arithmetic progression, it should be a plus n minus 1d. So since n was 10, 10 minus 1 is 9d, right? Should be equal to 25. So a plus 9d should be equal to 25. So a is already 40. We are already given the value, right? So let's substitute here. So a is 40. 40 plus 9d is equals to 25. So of course the only unknown is d. So 9d is equals to 25. We're going to minus the 14. So from 25, if you subtract of 40, it's going to give you minus 15. So the value of your d should be equals to, minus 15 over 9. Of course, if we cancel by 3, it's going to become negative 5 over 3. So every successive term is going to decrease by 5 over 3 seconds. So find the total time taken to swim 10 lengths using Mrs. Wong's program. So we need to add up each and every one of the term, right? Because T1 would be the time taken for the first length, T2 would be the time taken for the second length, and so on and so forth. So when we want to calculate the total time for swimming 10 lengths, we are talking about S10, right? So what is the formula for arithmetic progression for sum of n term? It is n over 2 times 2a plus n minus 1d. So that's the formula, and we know that the n value should be 10. So we're going to substitute this or replace this n and this n with 10. And what's the value of a? A is of course 40. We already have it. And the value of d we just found earlier, which is minus 5/3. So all that we need to do is to substitute all the respective values accordingly. So n is 10, a is 40, and n is 10 again, and d is negative 5 over 3, which is what we get here. So the rest of it is just simple computation. So 10 over 2 is a 5, twice of 40 is a 80. From 10 you minus a 1, that's a 9, and the minus 5 that I just copied down. So let's simplify further. 9 times minus 5 that is going to give you a 15. So what we're going to have inside a bracket, it should be negative 15. 80 minus 15 times a 5 should be the answer, which is 5 times 65. And totally it's going to take a total time of 325 seconds to swim 10 lengths of the swimming pool. Now what happens now? One of the members of the club, which is he is called Alfie, devises a different training program. In Alfie's program, the time taken to swim the first length is 25 seconds, and the time taken to swim the last length is 40 seconds. That means it's progressively increasing in time. The times taken for each of the 10 lengths are in geometric progression. It's going to increase geometrically. Susie swims 30 lengths. She swims the 10 lengths using Mrs. Wong's program, and then she swims the 10 length taking 25 seconds for each length. That means she is going to maintain a constant timing of 25 seconds for each of the length, and then she swims the 10 lengths using Alfie's program. And the length of the pool is 35 meters. So we can see she's going to use 3 programs. One is okay, what we have calculated Mrs. Wong's program using the arithmetic progression, and then she's going to use another 10 for Alfie's program, which is in geometric progression, and she's going to take another 10 length using constant timing. Okay, so that is how she's going to finish 30 lengths. Find Susie's average speed for her swim of the 30 lengths. So now let's work out. Okay, the first length is 25 seconds. So A equal to 25. Then she is going to use Alfie's program to do 10 lengths, right? So N should be equal to 10. And we know that it is a geometric progression, and we are told that the last length is 40 seconds, mean T10 should be equals to 40. Now what is T10? Okay, this is geometric progression. The formula is a r to the power of n minus 1, where the n is going to become 10. So a r to the power of 10 minus 1, which is 9, is equals to 40. And we already have what is the a, right, which is 25. So let's put in that. 25 times r to the power of 9 is equals to 40. And r to the power of 9 should be 40 divided by 25. R to the power of 9, 40 and 25 can be simplified. It's going to become 1.6. So the value of r, okay, the common ratio is going to be 1.6 to the power of 1 over 9. That is going to be the common ratio, okay, for Alfie's training program. So now she is swimming 10 lengths using Mrs. Wong's program. Okay, so let's go to Mrs. Wong's program first. Okay, so S10 is going to be, we have already worked out in the first part, it's going to take 325 seconds, right? From first part we worked out for 10 lengths how long, what would be the time taken. It was 325 seconds. Next, 10 lengths using 25 seconds constant timing for each length, right? So next 10 laps is going to be, so the time is going to be 10 times 25 seconds for each of the lengths. So 10 times 25, so she is going to take 250 seconds for the second 10 laps. So she has already completed 20 laps. Now let's go for the last 10 laps using Alfie's program. So for the last 10 lengths, so we need to work out what is S9. We already know what's the value of A as well as what's the value of R. So we're going to use the formula A r to the power of n minus 1 over r minus 1, where the A we are going to replace it with 25, R with 1.6 to the power of 19, and then this R is also going to be the same thing. So let us evaluate, okay, what is S10, and of course if we put in all the values, and okay, when we press the calculator, it's going to take 319.797 seconds. So that is going to be the total time taken for using Alfie's program. So now what would be the total time taken, okay, for this 10 lap, and Alfie's 10 lap? So total time for 30 laps should be equals to, this is from Mrs. Wong's program, this is from the constant timing lap, and from Alfie's program we're going to have 319.797 seconds, and the total time taken by Susie is to add up all the three timings together. It's going to become 894.797 seconds. That is the total time for 30 lengths. Now what about, because we want to calculate the average speed, right? So we need to work out what is the total distance. So total distance is swims 30 length. The length of the pool is, okay, 35 meters, isn't it? So 35 meters for each length, and there are 30 lengths. She is going to swim 30 lengths. So the total distance traveled by her would be 30 times 35, which is going to give you 1050 meters. So now we have the total time for 30 laps, and we have the total distance for 30 laps. So now we can work out what is the average speed. So average speed is total distance divided by total time, which is 894.797 seconds. And if you press the calculator, we should be getting 1.17 meters per second as Susie's average speed for 30 lengths. Okay, so that should be the answer. Okay, so the next part, determine exactly 8 minutes after she starts to swim. Okay, so we are talking about Susie. Susie is swimming away from or towards her starting point. So we need to work out. So 8 minutes is equals to 8 times 60 seconds. The reason why we need to convert it into seconds is because all the problems we have been working out in terms of seconds. So 8 times 60 seconds is 480 seconds, right? So she swims the first 10 length using Mrs. Wong's program. So let's see whether, within that 480 seconds, whether she is in Mrs. Wong's program, or is she in the constant lab, or is she in Alfie's program. So Mrs. Wong's program takes a total of 325 seconds, right? First 325 seconds would have been in Mrs. Wong's program. So this 480 is bigger than this, so that means Mrs. Wong's program is completed, which means she has already done 10 lengths. Okay, first 10 lengths is completed. So now let's work out from 326 to t equals to 575 seconds. It's all the way is constant lap, right? So because after she finished Mrs. Wong's program, she is going to start swimming with a constant timing, 25 seconds per lap timing. And of course, if you were to do it for 10 lengths, so she would go up to 575 seconds. But she did not go up to 575 seconds. She only went up to 480 seconds. So time of constant timing lap, okay, is 480. From that we need to subtract away Mrs. Wong's, or the time taken for Mrs. Wong's program, which is 325 seconds. If we subtract that, okay, that means in a constant time lap she has spent only 155 seconds. Let's translate this 155 seconds into what is the lap number. So how are we going to do it? Because each lap she is going to take 25 seconds, right? So for 155 seconds, okay, so if we divide by 25, we know that she would have completed, okay, 6 laps in 150 seconds, right? Then she is going to have a 5 seconds extra, which is actually 6.2 lap, right? So that means it is almost, she has completed 6 laps and she is moving on to the 7th lap here. So first 10 laps completed for Mrs. Wong's program. Now she is doing, okay, the 7th lap. That means she is on the 17th lap. So every even number laps she is swimming away. Sorry, every odd number lap she is going to be swimming away, because first lap she will be swimming away, and second lap she is coming towards, third lap she is swimming away, fourth lap she is coming towards. So 17th lap is actually odd number lap, so that means she is swimming away from her starting point, and that's how we know whether she is swimming towards or swimming away. So she is swimming away from her starting point.